While I was working this week on my shaper model, suddenly I hear this kind of hissing sound, a bit like a fountain sound. And indeed, it is a fountain. It comes from below here in the corner. No, that's not junk, these are projects, that's not the same. And here in the corner there's a hole in the wall, and this is where it comes in the tap water system. Here's the counter, the meter, and the sound comes from there somewhere. So I called the company and they will come tomorrow to fix this leak. But to do this they need of course some workspace, which means I have to dismantle this workbench and this little shelf behind here. And when that's done, we will talk a bit about my little shaper project, what I'm working on. I will show you. We will talk a bit viewer gifts, and we will talk a bit centering for key slots. Alright, with all this junk out of the way, I would like to show you inside. I did put some light in there and there's absolutely nothing to see. But what I found, I installed some light here. Behind the lathe is a big oil spill, and it comes from the oil pump on the back side of the lathe. Is leaking, so something to take care of one of these days, maybe. Somewhere in a previous video I made this little tap wrench, and I said in this video that I can't put a knurling on because I don't have a knurling tool. And Tom, he watched this video, so Tom, thank you very much for watching my video. And what he did, he sent me a pen, Hilltop Machine Works. I'm sure you know Tom, Hilltop Machine Works. If not, there's a link in the description. And he also sent me a paper clip. That's always useful. And then a very kind little note, an American flag, and all this was in this envelope, of course. And this is really handy. Fractions and decimals to millimeters. Because if you talk about, for example, 0.0156, okay, I can figure out how much it is in millimeters, but 1/64 or 1/32, I don't know. I never learned this fractional system. So Tom, thank you very much. This is gonna be really helpful when I'm watching YouTube videos and people talk imperial, so this will translate to normal people numbers. Thank you very much. And of course he sent me this knurling tool. That's good. You know what, I'm gonna give it a try. So I'm gonna oil these 3 points, put it in the lathe and give it a go. I installed here a piece of hot rolled steel. It's just soft, it's a black bar as some people call it. I'm gonna use my old live center because there's lots of force involved with knurling, of course, so I prefer using the old one and not mess up my new one. To bring you closer to the action, I made this not even made in Germany clamp camera fixing system that I can adjust. This is made out of old camera things, and I hope it clamps because it's really a crappy clamp. So you can witness the action from close by. With oil on this thing, I dial in that both rolls are barely touching. These rollers are not straight, are not square with the workpiece, but they're a little bit in an angle. I like to use coolant not for cooling the part, but to wash away the little chips. Maybe put in gear. Let's check. That looks good. Just for fun, I'm gonna try this again in the same knurl, 0.2 of a millimeter deeper than this one. This looks good, but it's just for fun project, of course, and a little higher RPM. Let's see what happens. That looks better. I think this test was more than convenient. So Tom, thank you very much. From now on, everything that resembles a bit like a cylinder will be knurled, I think. And of course, I will take note of your kindness. A few years ago, I bought these blades, 2 millimeter wide. It works with mixed successes. So as you can see, sometimes these things just breaks. Now for my shaper model, I had to make a special tool that is here in the middle, 1 millimeter wide. That's not much. So I needed a tool holder. Now to make this tool holder, I need to hold this tool in place to make this slot. And of course that's where this part broke off. There are others somewhere on the floor. But I think now it works. So that's good. Parting off tool, slotting tool. And I was a little bit tired of breaking these small blades, so I bought a new one. So let's go back to the lathe and give this one a try. Let's bring you a little bit closer to the action. Too fast. I don't know if we have to say Yatsé when it falls off. So I made a perfectly useless little knob here. That's good, the finish is okay. So this slotting tool is good. Now that we talking carbide, the fun is when I bought this one, they were supposed to be yellow, but they're not. That's okay, they work perfectly fine. No problem with these. And then I thought I'm gonna buy cheap ones and expensive ones and see what difference it makes. So I bought these two boxes, and inside you can clearly see that they look exactly the same, and on the boxes is absolutely nothing marked, so I have no idea which are the cheap ones and which are the expensive ones. But they cut, that's okay. And then I bought this one. These are without a chip breaker. Straight line, these are good for aluminium, and here you can use the 6 corners, which means that this cutting edge thing here has no relief. So when I make my tool holder, the insert is a bit leaning forward to give clearance on this side, and to be good it should lean that side to give clearance on this cutting side. There is clearance, but almost nothing. I know you can hardly see it on camera, but trust me, almost nothing. Now, because I made this tool holder myself, I know this is soft steel, so my idea is to drill and tap 2 holes in here, and maybe put a little screw right here, so I can, it's a bit hard to show, but you're gonna get the concept. So I can change the cutting angle if I want to. I think that should be a good idea. Now, of course, because of my water leak and these people coming repairing, this will be for another day. What I was working on the little shaper model were these 2 parts. I roughed out the table and I roughed out the tool slide, the clapper box, not yet. And I did some experimenting to make a hand crank. Oops, it's escaping. So I was experimenting to make tapers. Now, to compare a little bit. Voila. The problem is now, of course, because it's cut off, is work holding. I have to drill 2 holes in here. One here in the middle and one here in this bigger ball. Now this ball is not really completely round, but whatever, it was just an experiment, see if it's possible. The next time what I need to do is leave the part on this little shank, leave it in one piece, so I can hold my part in a little vise and then drill the holes, because the part like this one, impossible to hold of course, but that's not really a big problem. I can start again because I have some spare material. I was looking for nice and straight material to make these very tiny parts, and I tried with nails, I tried with little balls and whatever. Didn't work fine because the steel is too soft. Then I thought, I have a whole box of old welding rods and they have been wet, so they're finished, they're game over. As you see, they fall apart. Now what's nice about welding rods, they are nice and straight and they are round, and the steel is a bit harder than a regular bolt, so it cuts very nice. I think this is a good idea. While I'm watching your videos, and I really have a good time doing that, sometimes I see people doing things that I think, why so complicated? I need, for example, to cut on this side a keyway. Now I see people put this piece in a vise, but first aligning the vise with the bed, and then it's a bit too low, and then putting shims below it, or maybe better work with a V-block, and then there's maybe a bit too much stick out, and then we're gonna use a machinist jack that tries to escape while cutting, and you're not always really sure if your part is in line. Let me show you an easy little trick to align a shaft on your machine. Voila! Now, the T-slots of your machine are always in line with the x-axis or square with the x-axis. It's complicated. Now on this machine, of course, the x is that way, so my slots are square. To cut the slot, the movement of the ram is of course this way. For a milling machine is exactly the same story. Before we install the part, first we're gonna center the cutting tool. On a milling machine is the same. You can rotate by hand the cutter and take a feeler gauge, for example, because we don't have a dial indicator. As you see, I don't have. So I took, to make it easy, a thickness of one, whatever you may choose. Doesn't matter. We're gonna align the tool inside the slot. I'm gonna feel the drag. It's not easy sitting down and not really clearly seeing what I'm doing. Right, that feels good. Now we know that the side, this side of the cutting tool is at a distance of 1 from the side of the slot. These slots are 14. Half of that, 7. The cutting tool is 8, thickness of 8. Half of that, 4. 7 minus 4, 3. But we have to decount a thickness of 1, gives us 2. So now that the tool is at 1 from the cutting slot side, we set 0. Because lots of machines, and also this one, has a problem of backlash, we have to take care of that. So we're gonna move, we set 2, right? Gonna move a bit more. Come back, set it at 2. Perfectly centered. Put your part in place and you can cut